Hello and welcome back to DevOps Fundamentals by SkillSpeed. In this video, we are going to talk about Docker versus virtual machines. In the previous module, we spoke about microservices versus monolithic architecture. Then we spoke about hypervisor-based models versus container-based models. And in this lesson, we will try and understand why Docker, and then why DevOps includes containerization. Then we will have a comparison of containers versus virtual machines. Then we will talk about Linux container performance, and then finally advantages of containers, or advantages of Docker in particular. Alright, so why Docker? There are a lot of advantages of using Docker. If you see that you get a clean, safe, hygienic and portable runtime environment for your application, that is one thing. And as we have spoken in the previous video, what you don't have to worry about the missing dependencies, packages, because everything you have been putting inside the containers. So you package the application along with its dependencies inside a container, and then you just deploy it wherever you want it to be deployed. A lot of things you can automate. You can automate testing, integration, packaging. Anything you can script, you can automate through Docker. It reduces or eliminates concerns about compatibility on different platforms. Now, whether it is your own company premises or your customers or clients, doesn't make a difference, because you don't need to bother about the platform at all, as long as the platform has the capability to run Docker containers. And most importantly, you don't have the overhead of the virtual machines, but all the benefits of the virtual machines along with the speed and the efficiency of the containers. Right? That's the power of Docker. Why DevOps cares, or why does it fit so nicely into DevOps, is again because of the obvious reasons. It makes the entire life cycle more efficient, consistent and repeatable. Because DevOps, when we talk about, we are talking about essentially the feedback loop. We are talking about dev, test, prod, again dev, test, prod, and the whole cycle continues all over again and again and again. So it increases the quality of code produced by developers, because they can test it in exactly the same environment what they are expecting that in production, which is oftentimes the reason for deployment failures. And it of course eliminates the inconsistencies between development, test, prod and customer environments. Now all the other reasons are fine, but because the containers are so lightweight, addressing significant performance, costs, deployment and portability issues which are normally associated with virtual machines, that becomes very, very efficient in case of containers. And without all the overheads of the virtual machines which you get, because in case of virtual machines, you do get, that is one of the reasons why they are pretty heavy, because each virtual machine needs its own place to run before it can actually host the applications. This is one example of or a comparison between virtual machine architecture versus container architecture. So if you see here, the most important components to understand is that we have the server, we have the host OS, still here it is common. The most important elements which are not there in containers and which makes all the difference is the hypervisor layer and the guest OS layer. Now these two are the major reasons of a virtual machine overhead, because each guest OS needs a minimum amount of RAM and CPU and disk space to run efficiently. And that is something which we are talking about without talking about the application, because application comes into picture later, right? So all these things are not catering to your business. This is not efficient for your business at all. What is your business? The business is applications. And before we reach till the application, all these resources we have to provide in order for the guest machines to run properly, which is completely eliminated in case of containers. Yes, of course, we do have a couple of overheads, but that's negligible compared to virtual machine architecture. And that is one of the big advantages over virtual machines. Let's say if you have a piece of hardware, if you see here, let's say this is the same piece of server on which you're running virtual machine, and exactly same resources you have in this Docker host as well. If you are running 10 virtual machines on the virtual machine environment, you can run hundreds of containers in the container-based environment. That's how it compares together. Virtual machines versus Docker. Now, if you see here, virtual machines applications include not only the application, but also the entire guest operating system, which we have been talking about, and which take a huge amount of resources. RAM, if you talk any basic application today, or any basic operating system today, any Windows server or a Linux server, at a minimum, you would need maybe 1.5 to 2 gigs to run the operating system. You would need easily maybe 5 to 7 gigs of disk space, and at least one CPU you would need just to run the operating system. And then on top of all these resources, you would need additional resources for the applications. Now, in case of Docker, all these things are completely eliminated. Whatever you need, it's just for the application. Docker provides base images that contains the OS installations we can start from. So what happens is the OS is not more than an application running on the kernel. Now, to put things into perspective, in case of a virtual machine, if you want to install Ubuntu, typically we are talking about maybe 2 to 3 gigs of the size of the image. Whereas an Ubuntu Docker image, is the typical size for that is 100 MB or maybe 150 MB max. It's even lesser in some cases. So you can understand, you can see the difference in the amount of resources it is supposed to use. Performance also, if you speak, to create a virtual machine, it takes 8.26 seconds on an average. That is, again, we are talking about once all the automations, everything is there in place. You have all the scripts, everything is there. You just need to probably give the host name, a new host name, unique one, and a unique IP address. In case of Docker, it takes hardly 5.5 seconds on an average, right? In fact, in some cases, the gap is even more. Creating and rebooting a virtual machine 5 times could take more than 600 seconds. And again, I'm talking about one of the most optimized environment here. The same thing in Docker would hardly take 48 seconds. So probably 10 times or more than 10 times is the difference in terms of boot. Taking snapshots, in case of virtual machine, it takes about 32 seconds. In Docker, it takes about 21 seconds. So everywhere you see, when you talk about speed and efficiency in terms of resource utilization, everything Docker wins hands down. So now let's see why exactly Docker containers are very lightweight. I mean, the reason is obvious, because you have the guest OS. Now, when you talk about the boot time, in case of virtual machine, every machine has its own guest OS. So of course, you need to bring the machine up, just like a normal virtual machine you will bring up. So you need to bring up, let's say, Windows server or a Linux server, which will typically take maybe, about a minute or so. Or if it is very fast, it will take maybe 25 to 30 seconds. In case of containers, however, you don't have to bring up the OS. The OS is already up. What happens is, when you create a new container, it's similar to or almost same as starting a new process, which hardly takes seconds. And in some cases, when you give the docker run command, which we will be seeing in one of the future lessons, which is needed to create a new container, it takes less than a second. Sometimes it takes less than a second to bring up a container. So now let's summarize the advantages of Docker. So with the help of Docker, you get pretty fast deployments, because the whole way of working has been changed, and it has been tested already. So you do get faster deployments at a very high pace. Isolation, you have the isolation without the overheads of the virtual machines, which is very important, because isolation was there in virtual machines as well. But Docker gives you the same capacity or the same capability without the additional overhead. Portability, it works on My Machine syndrome, which we have spoken about probably in Vagrant lessons. So that is no longer there. Once built, it will run everywhere. You can ship it anywhere. You can run it anywhere. Resource usage, you can limit the resource usage to a very optimized way. It is going to work for you. And as we have seen, it takes extremely less amount of resources compared to virtual machine infrastructure. Dependencies simplified, because everything, whatever dependency is there, you are putting that inside the containers along with the software code. So that eliminates a lot of complexity, which is not needed later on. And of course, once you have created an image or a container, you can definitely share with anyone you like within your organization or outside your organization as well. So it really helps in collaboration as well. So that's it for this video. In this one, we have learned why Docker is needed, first of all, how it is related in DevOps, and how it is optimizing the overall DevOps processes. Then we spoke about container-based approach versus virtual machines. And then we spoke about advantages of containers, or to be more specific, advantages of Docker. Any questions, do raise a support ticket and we will be glad to help you. Thank you for watching and see you in the next video.